Hi, everybody. We're going live. Sorry for the delay. Very, very good to be here. Thank you for your patience. Just literally came from one live stream to this one. Welcome to the Data on Kubernetes live stream number 87. Very, very excited to be doing this today and very excited to be with you. Finally, Leonardo, we've been talking about doing this for a while. It's good to have you with us here today. How are you doing? How's everything going?
Yeah, I'm fine. Thank you for asking. Yeah, everything is fine. I'm just suffering here in Brazil because here is so hot right now, and we are just in the winter, so you can imagine it.
Okay.
How is the weather?
Yeah. How hot is it there?
Sorry,
what temperature? How hot is it there?
Oh, right now I think that's almost 35 degrees Celsius.
Well, that is quite hot. Yeah, that's hot.
Yeah, quite hot.
Yeah, that'll do it. Also, before we get started, can you just tell us a little bit about yourself, your background, how you started working with Kubernetes?
Yeah, sure. Well, I started as a Java programmer in 1996. So I got a few years working with computer science and working for many consulting firms. And then I started in 2000 as a Java architect. I got my bachelor's degree. And since then, I've been working for different consulting firms, mostly with financial institutions, some governmental projects. So that's it.
That's good.
Yeah, a lot of years working with different technologies. So you can imagine that in 2000s, I was working with that enterprise Java Beans. Do you know this?
Yes. Yeah.
Yeah. And now I'm working with Kubernetes since 2014.
Oh, wow.
2014, 2015. I started with Kubernetes using that kubapp script. I don't know if you remember this. Yeah, kubapp shell script was a script created by Joe Billis to start the Kubernetes environment. So I believe that I was one of the first guys here in Brazil trying to run in Kubernetes environments on private clouds environments.
Wow! So it's not often that we hear someone say that they worked with Kubernetes since 2014. So good for you. You have a lot of experience. That's nice.
Yeah.
Okay, and so what are we going to be talking about today? If you want, you can start. If you want to share your screen, you should have a green button towards the bottom with an arrow pointing up.
Okay, perfect.
No worries. We're always talking about complex technology.
Let me locate this.
No worries. Like we're always talking about complex technologies, but few technologies can be as difficult to work with as Zoom. So don't worry about that at all. When you find it, just click and you should be good to go.
Okay. Just a moment, I'm closing some tabs.
That's okay.
In my Chrome.
Yep. Don't want people to see your Bitcoin. That's okay. Don't worry.
Yeah.
That's all good. And just a reminder for folks, if you have questions, feel free to put them in the chat and we can answer them during the live stream.
Okay. So let's get started. I'm going full screen, so you may interrupt me if you need to. Okay, guys. Thank you. I'm going to talk to you right now today about Cloud Native Microgateway, and Cloud Native Microgate is an approach to re-architect the old-fashioned API gateway stuff. So we're going to understand how you can take an API gateway and put and fix some aspects of the architecture so we can use it with istio and Kubernetes. Okay. So about me, I talked a bit about me, but my name is Leonardo Silva. I'm from Brazil, and I started as a Java programmer in 1996. Fast forwarding, I'm currently working for a firm called Pismo, and I'm CKA. I got my CKA about 2 years ago, and I'm trying right now the CKS. So without further ado, let's go.
Okay.
So the agenda, yeah. So the agenda is I'm going to talk about the challenge, what motivated us to create this architecture, giving you the guys some background about what's in monolithic API gateway. I don't know the audience if all guys are aware of what's an API gateway. So I believe that's worth to mention that there are different approaches to how we can deal with an API gateway and connections and so on. I'm going to talk something about essential functions that we could consider when we are trying to choose an API gateway and deliver an architecture in cloud native environments. About the platform that we are working with. So I'm going to talk about Kong API and istio, just a bit. And then the Microgateway architecture, we are going to deep dive and talk about how it works and how gitops can help us to deliver to our teams and customers. Since we are talking about data, since we are in a meetup about data on Kubernetes, I think it's worth also talk about how we are dealing with the data on Kubernetes to our microservice and the key takeaways at the end, okay? So what's the challenge? What motivated us to create this Microgateway architecture? So this company that I'm working with, it's called Pismo, and the Pismo company is responsible for creating something called banking backend. So basically, what we are doing is recreating all that features that digital and normal banks have running on mainframes, for example. So we are creating this on cloud native environments running, for example, on AWS or Google Cloud. Since we are dealing with this financial transactions, we have a lot of challenges to deal with. For example, currently we are doing almost 4.8 million requests per hour. So you can imagine that we have no place to get some errors on our platform. And because of that, we must offer an SLA, a higher SLA, now 99.99%, because our customers cannot suffer with interruptions or incidents, because there is a lot of money in those transactions. So we should take care of the platform. You should keep the platform up and running. We have different challenges also. For example, we have teams that are increasing. We have newcomers to our team. We have different features. We have to create different APIs. Each API has its own context, has its own features involved. For example, different security environments, different requirements for authentication and authorization. So we must keep up with the markets. And we also have, you can imagine different threats coming from hackers and people trying to steal credit card data and people trying to manipulate banking accounts. So you can imagine that we have these challenges all at the same time. So the Microgateway is an option that we can use to deal with this. We are going to see this in this presentation. So this looks a bit scary at the first glance, but calm down, let's understand how we can deal with. So what's a monolithic gateway? First of all, a gateway is some connection elements that's part of an ecosystem that's greater than that. So an API management is a product, okay? And an API gateway is something that's part of the API management. So API management, you can imagine that's all related to how do I publish APIs, how do I keep them running, how do I govern them, how do I create policies and so on. And the API gateway is this guy related to the data plane. So basically when an external client wants to connect to some API, for example, accounts API, this client is going to connect to some external elements, for example, unload balancer. There are many different interconnection elements, but I will keep simple right now. So the client connects to the external load balancer, and the load balancer is connected to the API gateway. So the API gateway in this monolithic approach receives all connections, okay, and do all that stuff related to routing and security validation and so on. And the API gateway, even the monolithic API gateway, can run on Kubernetes. This doesn't mean that it's cloud native, okay? It's just a Kubernetes here can be used just in a cool environment that gives you some resilience, logging, and security. But in this architecture, the API gateway, you can imagine it as a big box that is receiving all connections from different customers and routing to different APIs. So we have many different problems with this approach. For example, it's not easily scalable. Yeah. So if you can create more API gateways, normally you are going to ask it to your vendor if this API gateway is able to scale with Kubernetes. Not all products do that. So it's important to understand that being an API gateway cloud native means that we can work with these cloud native features like easy scalability and monitoring and security. And one problem with this approach is that normally the API, when some API wants to call another API, it calls back the API gateway, and the API gateway has the route information and calls back and calls another API in the flow. So you can imagine that this doesn't scale very well. Okay. The essential functions of an API gateway, I just put some essential functions here, but I'm not going to explain each one of those. So I just selected a few that I'm going to talk about to demonstrate that those essential functions must exist, but not exactly just on the API gateway. If you take a look, on the previous slide, you can imagine that. Let me go back here. You can imagine that the API gateway is doing a lot of stuff. But if you are going to take each one of those essential functions, you are going to see that you can pick one or another and modify your architecture so istio, for example, or Kubernetes could take care of it. For example, route deployment. We are going to see that Kubernetes can do that for us. Load balance is something that Kubernetes with Istio can do for us, and so on. So the request routing that I selected here is one of the most important functions that I can have on an API gateway, because the API gateway solely exists to do this, to request routing. Okay, so the API gateway must be able to receive and request, and based it on some criteria, it can delegate to another interconnection element. It can send to a microservice. It can do request transformation. It can filter and so on. So it's important to have an API gateway that exists to configure, to adapt your environment and create rich request and routing schemas. Plugability is also very important. So the API gateway cannot be a monolithic box that you can put more and more code, and each line of code that you add to your API gateway, you are creating essentially more bugs on it. So it's important to use an API gateway that you can separate different features on more testable elements, components, for example, and you are calling these plugins, okay? Another important thing is observability. So you cannot operate anything if you cannot, for example, understand what's going on. It's impossible to try to see, for example, logs from millions and millions of requests one by one. You have to keep your observability updated, and you have to use best tools to improve your observability. And on this observability, you can also create your alarms and dashboards for your internal use or for your customers, for example. And we cannot forget something that's very important also, the policy enforcement. So what's this policy enforcement? Policy enforcement is nothing less than you create mechanisms to understand who, when is using your APIs, your environments. So we're going to see that policy can be applied in different stages of your architecture, on pipelines, on the runtime. So it's very important. It's very important to create this enforcement, so you can create, for example, policies related to PCI environments. You can create policies related to financial compliances and so on. So about the platform, if we are talking about cloud native, we have many options, but we choose to use these three main components in our platform. So Kubernetes, I hope that's all all of you guys know it, but maybe Kong and Istio
Very good choice.
you don't.
Very good choice.
Yeah. Yeah, Kubernetes, there's no need to introduce it, but Kong is worth to mention that it's an API gateway, open source API gateway implementation. It's already in that CNCF graph that has a lot of technologies. I don't remember the name of it, but if you go to the CNCF page, you are going to see that a page that contains lots of components, and Kong is there. So Kong is an open source, is very flexible, highly configurable, very, very fast, small footprints, easy to create stuff on it, easy to create custom plugins. If you are not comfortable in create something, you can buy it. You can buy enterprise license of it. So, and Istio, and I'm going to talk about Istio a little later. So I talk about Kong, but Kong is not just for Kubernetes. You can use Kong on-prem. You can use Kong outside of Kubernetes. You can use it just with Docker. You can choose your model to run it. But it offers something that's very important. It's very important to us. That's this small footprint. So when we boot, we do a boot of a pod running Kong. It's just a couple of seconds, and Kong is up and running. And it's very easy to scale because we are using a mode. Let me say a mode is just like how you configure the Kong. So we are using a stateless. I don't know if I can say stateless, but it has a state, but it's not. The Kong is not connected to an external database. Okay, so the database is running inside the Kong, and there's no need to keep state between Kong instances. So you can create 10 pods, dozens of pods running Kong, and then work it independently. Okay, and Kong also has this gRPC routing and work with encrypted credentials, and it's very interesting. Other thing that's worth to mention is that I can configure the routes inside Kong using just plain Ingress resource. So if I'm going to show you this, but Ingress resource is that Kubernetes resource that we can define routes for HTTP endpoints. I'm going to show an example in a few minutes. Okay, with Istio. So Istio is another piece of the puzzle. And why are we using Istio? Istio offers many fantastic features. For example, with Istio, we can deal better with how we connect microservices. So we use Istio to understand how an microservices is calling other microservices, how the flow is how the data is flowing between them. We use Istio to create, for example, policies. We use Istio to create the work better with load balancing, and we use Istio to our observability. We can create metrics from Istio, and it's fantastic. So without Istio, we are going to have many problems. For example, we are going to deal with a canary release manually. So Istio is helping us to do more deployments with more security, and is giving so much performance to our teams and engineering and SRE teams. So if you don't know istio, get to know it because it's worth it. Okay, so istio and Kong and Kubernetes are our environments. And what's the Microgateway after all? So Kong is a gateway, okay, but Microgateway is an architecture. So Microgateway is an approach when I'm stopping to work with that old monolith way of thinking, and I'm preparing to break apart routes and configurations, and keep the gateway very, very near of the services endpoints. So you can imagine a Microgateway as something as an exclusive gateway for some API, for example. So instead of keeping that monolith, I'm creating many instances of APIs microgateways, so I can take those microgateways and do whatever I want to solve. Basically, I'm going to show you this in a few moments. So Microgateway is a lightweight approach to deal with API gateway stuff. So let's deep dive in and understand how this Microgateway works. So Microgateway is very, this draw looks similar to the previous one, but has some important things here. For example, the client is the same, the external load balancer and other connection stuff is the same, the Kubernetes the same, but here we have the Ingress Gateway. So I have this Ingress Gateway component. This is part of the istio. And this guy is doing the first connection, the first element of connection. So all connections are flowing from our load balancer to our Ingress Gateway. And the Ingress Gateway is doing the first, is the first element to handle this for us. And this has some advantages of putting the Kong. Okay, so I'm going to talk about this later. So the Ingress Gateway, this istio element, is receiving the requests, and based on some criteria, is redirecting the request to another Microgateway. Microgateway here is a Kong, is a Kong instance, and the Kong is receiving this request, is doing some manipulation and redirecting to the API. There's something important here. Because we are using istio and Kubernetes, there's no need to an API call back the Microgateway to pass the flow to another API or microservice. Each different APIs can talk each other, and I'm losing nothing because istio is taking care of if there are some permissions to do that, and how it's working, and policies and so on. So the Microgateway here is just working basically with north-south requests, and the east-west is occurring between those microservices. Okay. So the Ingress Gateway here is doing something important to us, that's TLS termination. So any client, any external client can securely call our load balancer, for example, but the TLS termination is handled by our Ingress Gateway. We can also configure the Ingress Gateway to do TLS termination on the Microgateway. So there are many different options. The context routing is important because the Ingress Gateway must be kept simple. To deal only with great contexts. So imagine that your API has a path, for example, host/context/ the name of microservice. And the Ingress Gateway is dealing with this first context filtering, okay? Rate limits, we also can use the Ingress Gateway to do some rate limiting and some policies that we can, for example, create inside the Ingress Gateway. For example, we can validate JWT tokens on Ingress Gateway. We can validate TLS connections on Ingress Gateway. We do not need to pass this to the Microgate to do that. So there are a lot of options here in the Ingress Gateway. If you want to know more about the Ingress Gateway, there are plenty of documentation on istio websites. And the Microgateway here, the Kong, is doing the load balancing using istio, the istio information, but we can load balancer even better. We can create specific routing. We can, for example, by examining some header or some payload field, you can, for example, do better balancing between services, okay? And the most important is that we are using our Microgateway to do some authentication and authorization validations. So we can configure authentication per API if you want to. If you, I don't know if you guys are aware of different RFCs related to OpenID Connect and OAuth2, but we can have different authentication methods, and we can configure those different methods for different microgateways or for different routing if we want to. So deep diving even more, as I said before, the north-south traffic is coming from the outside into istio Ingress Gateway. And the istio Ingress Gateway has this resource called gateway that we use to configure basically host names that we are going to process inside this Ingress Gateway, okay? And we have also some elements. For example, the Kong proxy is the service that is receiving the request coming from the istio Ingress Gateway. And we also have the virtual service. The virtual service is a configuration that binds some gateway to our services. So you can see this icon here, that's a button. Those are istio elements, and the Kong proxy is just Kubernetes components deployments. But if we are using Kubernetes, we can also use the Kong Ingress controller to configure our routing. So instead of offering different approaches to configure routing, for example, specific endpoints and scripts and so on, we can just create simple Ingress resources and our route is there, okay? So what's a virtual services? I added this example so you guys can have at least something to remember how this is going to work. For example, in this virtual service here, we have the name is Kong virtual service. You can notice that we have a namespace, for example, accounts, and this virtual service is receiving all requests coming from the accounts context that I'm calling, that I'm showing here is the context filtering, and is taking all those requests and sending them to the Kong service destination route. So the Kong service is just like here, okay? Going back to this architecture here, we have also the routing configuration that I'm going to show an example in a few minutes. And the routing configuration is receiving those requests coming from that context and sends them to the specific APIs. And the APIs are basically pods running on Kubernetes. And we have on number 6 here, the authentication and authorization configuration. So we are also adding this stuff related to security to our routing. There is something interesting here. We have the blue boxes. The blue boxes are the ones maintained by platform teams, okay, SRE, platform, and so on. And the yellow boxes are maintained by engineering teams. So we are also using this architecture to separate concerns and separate responsibilities. So the platform team is responsible for some more structural things, and engineering teams has focus on routing and authentication configuration. So an example of route configuration here. You can see that we have this Ingress Gateway Hef. The Ingress Gateway Hef is the name of the Microgateway. This is very important because if we're going to run different API gateways, different micro gateways, each one of those gateways necessarily has to be named differently. So if I have a micro gateway called a accounts gateway, okay, this can be used by some accounting contexts. If I have another different ingress, a different instance of micro gateway, not instance, but different deployments of micro gateway, I can give to it different name, and I can differentiate those connections, guys. Okay, you can see that I can configure here the plugins. So in the path, I have the subcontext filtering. So if I'm using the Ingress Gateway to do more context filtering, I can use the route configuration, this Ingress resource here, to be more granular. I can differentiate better. I can send to different microservice backend definitions and so on. Remember that previously I was redirecting the connection to Kong. Now I'm calling the microservice name, okay? And we cannot forget to add our policy enforcement here. So istio offers many features, many resources related to the policy, authentication policy, and peer configuration and so on, and you can use that. But we can also create our own policy enforcement. For example, using open policy agents, you can create admission controllers to verify your routes, to see if those routes has the correct plugins. You can create your, for example, Kubernetes operators to verify if all plugins are configured and so on. So there are, inside this cloud native environment, we have different ways to create this enforcement. We are going to use the open policy agents to create our points of policy decision. And maybe in the future, I have more about this to tell you guys. So let's go. So if we are working on cloud native environments, we are not supposed to forget about the security. Okay, we are dealing with credit card numbers, bank accounts in my context, but we can create mechanisms to give more usability to our engineering teams to maintain those API gateways. Okay, you can create better tools to our platform teams to create and maintain and operate the Microgateway instances. So how do we deal with that? We can see here that we have different roles, the platform teams, as I mentioned before, and the engineering teams. But basically, this pipeline here is related to different aspects of the API, Microgateway API lifecycle. So for example, the platform teams, when they need to, for example, change the version of the Kong, they open an APR to the API Gateway core, for example. This will trigger the CI pipeline, and we're going to release a new version of Kong. We are not releasing new routes. We are releasing, for example, new plugins and new policies and so on. Okay, and this is done using the gitops practice. So we commit to the Git, for example, and the pipeline executes and process and do a release. And when this release is done, the Argo CD, the Argo is a product from the Argo guys. I don't know the name of the firm that create Argo. No, I forgot. But okay, the Argo CD is configured to see this release on Git, and it applies using the Argo rollouts to the many environments that we have here. Okay, so here we are deploying a new Kong version, a new Microgateway version. But when the engineering teams want to create new routes or configure new plugins, is different, a little different. So the engineering teams are going to open the PR the same way, but now they are manipulating the routes and plugin configurations. So pipeline is going to be executed, and a new release is going to be generated, and the Argo CD is taking those release artifacts and applying on different environments for different teams. Okay. And we can also create our policy enforcement here. So what kind of policy we can create? We can do validation, YAMLs validations. We can test if our plugins are working. So in each one of those pipelines, we are really executing the Microgateway version and we are also executing requests to see if this is working perfectly, okay? And yeah, you can imagine many things to add here. So including security validations, okay? Yeah, in fact, we are executing also some security stuff here to validate if the routes make sense, if the permissions are going to work, okay? So the Microgateway should be treated as a product. What does this mean? In fact, the Microgateway is something that's maintained by the platform teams, okay? Because the platform teams the platform team is the one responsible for doing all the release management. So we are very we are responsible for example, dealing with bug fixes, testing plugins compatibility, creating new plugs, doing security checks, and so on. Okay. And we should also, if you are using Kong, you should also take care of the plugins. If you are using open source plugins, you can check if the plugin has some bug, if some vulnerability, and so on. We are also using Kong Pongo. Kong Pongo is a tool that we can test different plugins. This tool is basically used to test plugins. So for example, you can pick a specific Kong version, for example, 2.0, and test all the plugins against that version. So very useful. It's very useful. And we are also doing each tests using K3D on our pipelines. So our internal customers are the engineering teams in this case. So when some engineering team wants some new functionality related to Kong, it's demanded to us, to the platform team, and the platform team is in charge of doing this, all that stuff. Okay. So here, one of the pros and cons of microgateways that I selected. So pros, you can see DevSecOps friendly. So all these microgateways is not only to deal with that multitude of requests, but also to offer to our engineering teams better UX. Okay, so if you are willing to help your engineering teams to improve their performance, you really want to invest on better tools, and Microgateway can be considered as a tool maintained by the team, the engineering teams, and the platform teams. Okay, so the pros also flexibility is very flexible and very scalable, but when we are using microgateways, we are also shortening blast radius. What does this mean? This means that if, for example, an engineering team creates some invalid configuration, okay, the gateways team is going to suffer something, but not all the gateways. Okay, so we're dealing better with incidents, and the microgateways can be highly customizable and flexible. But we have also the problems. For example, it's very difficult to create governance and policies to these environments. You can use many tools and frameworks and so on to deal with this. The control plane can have an increasing complexity. So instead of having only one API gateway receiving all requests, you have to deal with different connection elements. We have data flowing from istio, passing to your microservices and back to the istio, and so on. So this can be a little difficult to understand if you don't have the monitoring tools working accordingly. And the platform team can also become a bottleneck. So if the engineering teams are not willing to help the platform teams on that, on the maintaining the gateway. The platform team can become a bottleneck because the platform teams will be involved in all incidents and monitoring and configuration. So you have to put some policies, but some cultural aspects when you are creating these micro gateways architecture. Okay. So let's talk a little bit about the data on Kubernetes and see how we are dealing with this. So data on Kubernetes. So my first point here is that not all your teams are data specialists. You really need to understand what's your team, how your engineering team works, how your features are delivered, okay? And if you understand this, you are going to know the team's capabilities. So you are able to decide, am I able to create my own database on Kubernetes, or am I able to maintain for example, my NoSQL database running on-prem? Okay, this is very important. And if you know your team capabilities, you are able to understand what kind of service you are going to use. In our case, we are experimenting the Cockroach DB. We did some experiments on-prem, on our cloud environments, and we also experiencing some performance gains using the hosted Cockroach DB. So the Cockroach DB is already running on Kubernetes, but is maintained by some provider. Okay, basically we are using managed services because the cloud providers are in charge of doing these SLA guarantees. Okay, they are in charge of the scalability issues, and basically the managed service that we are using right now are the DynamoDB, Aurora from AWS, and Spanner from Google. Okay. We cannot forget that even if we are dealing with different NoSQL or SQL databases, we should always validate our data architecture. So what's the data architecture? Basically, this architecture, it's going to answer how my data is going to be persisted, maintained, evaluated, and so on. So you should validate to understand if you are going to acquire or build, and if your team is able to build something, you are going to need more specialists, for example, data architects and people we focus on this thing here. And we are using also a product called Proxy SQL. We have a blog about this. Basically, Proxy SQL is a, you can imagine that's a service exactly that receives these SQL requests and do some stuff with them. For example, multiplexing and multiplexing. I know there's something related to manipulating the queries, so the queries are optimized on the fly, and so on. So very interesting, this blog here. So we're going to the end here. So the key takeaways that I would like to let with you guys is that we need to understand your challenges and threats. And you should plan the better API strategy to attend your needs. I presented here the Microgate, but maybe the monolith is a better approach. If you, for example, don't use the Kubernetes, I hope you are using Kubernetes, but if you don't use Kubernetes, maybe you are using EC2, the API gateway can become a problem. The Microgate approach can become a problem, okay? So plan before you implement it. Yeah, you need to understand your stack. When I'm saying here understand, is that do not put, for example, istio on production without really understand what's going on, okay? Do not use Kubernetes if you are not aware of how Kubernetes works, in fact, and uses all the resources. For example, how Kubernetes works, disks and network and connectivity like load balancers and so on. You have to work on good UX to your engineering teams, okay? This means tooling, this means investing in good documentation, support and so on. And don't forget to embrace the policies and governance. So create mechanisms that enables you to control what's running on your environments, how things are going to be configured on your pipelines, on your Kubernetes, on your istio, and so on. And if you understand and if you are okay with the Microgateway, you are able to kill all the aliens. And that's it.
Slow. Wow, Leonardo, you covered a lot of material in 1 hour. And it's funny that we started out. It's funny that we started out by you explaining that you've been working with Kubernetes from starting from 2014 and 2015, and this is our live stream number 87. And I don't think I've ever had a talk where we've got so much information in 1 hour, but at the same time, in a really easy to understand way. And I always say that because I'm not a super experienced Kubernetes practitioner, but very, very well explained there. And also, it's nice too that it's not that you're just trying to create hype around a technology, saying these are the ones that worked. I really liked what you mentioned as well too. And could you maybe talk a little bit more about saying really know your stack? For you, what does it mean? Is saying like, what does it take? What are the mistakes that people are making when it comes to really knowing their stack? And at what point would you say that, okay, like you really get it, rather than, oh, I saw this article on Hacker News about this technology, let's start using it? How do you do that in a good way?
Yeah, good action. Good question. Well, when I started to use Kubernetes, it was 2014, and Kubernetes offered me a lot of resources. In 2014, I believe that it's already existed, the serves, deployments, maybe Ingress, and I don't remember all, but a lot, okay? But if you take a look, for example, only in Kubernetes today, man, we are going to see dozens of different capabilities and features and configurations and so on. So what I mean when I said you must understand is that you don't need to all of your team to become Kubernetes engineers, okay? But the team in charge of dealing on a daily basis with Kubernetes should become experts. Just because when we are in full productions environments receiving millions of requests, there is no time to guessing, okay? You must see the problem and enumerate very fast possibilities to deal with that and apply the fix if it's the case, or call your vendor and so on. So we are talking just about Kubernetes, but if you are adding istio on Kubernetes, and then you already have, for example, the cloud environments. So you can imagine that's a lot of information and a lot of things happening under the cover, okay? So there is no easy way to deal with Kubernetes. You really need to become a specialist. And if you are willing to become a specialist, so you are able to put Kubernetes on production. That's my point, okay? Yeah. And this is applied to istio, to Kubernetes, to Kong, or whatever technology you are using to do your production environment.
Yeah, no, I think it's a great answer. And I think that's what you touched on, is that it's not that everyone needs to become an expert, but that a very focused group of people probably do. And obviously, you know, that takes time, it takes practice, but like you said, you don't want to be in a situation where you're guessing with your fingers crossed, you know, praying to God that things are going to work out. That's for very exceptional cases, that strategy is all right, but that shouldn't be, you know, the normal approach. So anyway, that's a very good answer. We had some great feedback in the chat. You have a lot of fans. People really like you. So just so you know, there's been a lot of really nice comments here on yours. Yeah, something about love, because you explain things in such a nice way. And it's like I said, it makes it very, very easy to understand for someone who doesn't have experience, you know, dealing with these kind of APIs, working with technologies like Kong and Istio. It makes it in a way that it's not overwhelming, as some things with Kubernetes can be. So I just want to thank you for doing that. Definitely check out Leonardo on LinkedIn. We need to get you in our Slack as well too, because I think you could help a lot of people with the things they're working on. Very interesting to see how you are working with data on Kubernetes. Definitely going to check out that blog post as well that you shared. So thank you very much for your time today, Leonardo, and I hope we can have you back soon for a session in English, or maybe we could do a session in Portuguese. That could be cool too.
Portuguese. Yeah.
We can do that. We can do that.
My English is a work in progress.
No, your English is fantastic. It's better than mine, and it's very relaxing to listen to. So that's not the thing. I just think it's fun to do things in different languages. But
anytime, Mr. Farrell, when you want me to talk about some technology, just call me.
I will.
Okay.
I will. Don't worry. I definitely will. So yeah, like I said, we're still getting comments on YouTube. Like I said, you got some serious fans out there. So anyway, I think this is the perfect excuse to think about our next live stream that we can do. Maybe we can take a deeper dive on the approach and how you started working with data on Kubernetes, or we can think about different topics. But anyway, thank you very much for your time. Much appreciated. And we'll be talking to you soon. Okay. Muito obrigado.
Yeah. Thank you very much.
All right. Bye. Guys. Cheers.